Well, hello and welcome to some e-learning notes. So my plan for today in class was that we would work through some more of these notes about the shapes. Once I realized it was going to be at least a 2-hour delay, I figured we would just finish out this page of identifying, describing these 3D shapes, and then I'd have you guys work on the first couple pages of your assignment. Instead of trying to get the descriptions and the slices, I feel like the slices are going to need their own day. So we're going to do those on Monday. So for this video, we're going to work on filling out this page. We started this in class yesterday, but this part that you're seeing right now, that was kind of a rush. Then I'll show you what parts of the assignment I expect you to work on today. And by the time you're getting this, I should have the Google form posted for those answers. It's not going to be a lot. So I'm thinking, I didn't actually pass out the assignment yesterday. So you will have to work from the PDF, but I'll have a video showing you how to take something from Google Classroom into the app that I use called Notability so that you can write on it just like I'm writing here. So the first thing I want you to do actually is to pause my video. I don't want you to listen to me for a minute. I want you to try and fill out this table. So we did the rectangular pyramid yesterday. I want you to try and finish filling it out for the cone, the cylinder, and the sphere. And then start the video back up and see if you got the same thing that I did. All right, there's how I filled out mine. So some surprising things really are the zeros. So the thing to remember, edges are always straight edges. And once we get past the rectangular pyramid, all three of the other shapes up here all have curves. So they're not really edges. So the faces I think are pretty straightforward. We're looking for those flat sides. So you see 1 in the cone, 2 in the cylinder, and then nothing flat in the sphere. And the number of vertices, remember, are those sharp pointy corners. So we do see one at the top of the cone, but none in the cylinder or the sphere. So if we look at number 3, by the way, this is kind of a glimpse into my general math classes. This is from their textbook, so you can see how notes generally go for them. Number 3, compare the cone to the pyramid. Describe similarities and differences. So similarities, I would say they each have a vertex at the top. And that's opposite a flat base. But the differences and how you can tell them apart, pyramid comes from a polygon base. Giving it edges. That's really the big difference. Since the base has corners, then there are edges coming up from those corners. So that's the big difference. Now the cylinder versus the cone, similarities, I would say the circular base. But differences, obviously, the cone angles into a vertex. Whereas the cylinder goes straight up. It's not the technical way to say that, but it's enough just to analyze differences. It's what you'd be looking for if you were trying to decide which one was which. So what can you conclude about the faces, edges, and vertices of the sphere, just that it has none? It's all one big curve. Now, really what I wanted to get to, and what I was hoping to get to yesterday and it just didn't happen, were these examples. So in number 6, it says a pepper shaker is a three-dimensional solid. So that part I think we can all agree with. Any pepper shaker is going to be a three-dimensional solid. The important things here, apparently this three-dimensional solid has 5 faces, 8 edges, and 5 vertices. And our goal is to tell what shape this pepper shaker is. So if you wanted to, you could try drawing something, or you could think about narrowing things down. Remember the types of shapes that we looked at? Pyramids and prisms. That wasn't one of the ones, it was that very first example that we did yesterday, but it wasn't one of the 4 across the top of the page today. Pyramid, prism, cone, cylinder, sphere. These are our options, right? So if we're thinking three-dimensional solid with 5 faces, I know it automatically cannot be a sphere that doesn't have any faces. Cylinder is always going to have 2 faces. A cone is always going to have 1 face. So we're looking at either a pyramid or a prism. So with a pyramid versus prism, 5 faces, 8 edges, and 5 vertices. Rectangular pyramid would be one example. We have that in our table, actually. So this could be a rectangular pyramid. If it's a pyramid, it has to be a rectangular one, because those 5 vertices, we've got 1 at the top, which leaves 4 at the bottom. So it's got to be that rectangular pyramid. That's the most terrible rectangular pyramid I've ever drawn. If we start thinking about prisms, prisms have 2 bases. Now they can be different shapes, and you'd have a vertex on each corner of those shapes. So with the 5 vertices, this is going to tell us what we can do. We had on the first page of this, we had a rectangular prism, and that had 8 vertices, right? Because there's 4 for the top rectangle, 4 for the bottom rectangle. So that's more than we had here. It's definitely not a rectangular prism. Even if we think about a triangular prism, though, we've got identical bases there. But that's going to be 3 vertices at the front, 3 vertices at the back. That's going to have 6. So anything smaller than that's not going to be 3D. We can't have a prism with a non-polygon base. So triangle is the least vertices polygon we have. So that's the least number of vertices we can have in a prism, and 5 is less than that. So it cannot be a prism. It has to be a rectangular pyramid. All right, then next we have a container with 1 face and 1 vertex. So if we're thinking back, a pyramid is always going to have multiple faces because it's going to have the bottom, square, octagon, whatever it is, but then it'll have a face coming off of each of those sides. So it's not pyramid. A prism also is going to have at least the 2 polygon faces and then another one for every side. So it's not a prism. Could be a cone. We'll come back to that. Cylinder is going to have 2 faces, so not a cylinder. And sphere doesn't have any faces, so it's got to be a cone. And it's that kind of thinking that you're going to need to analyze, describe, and do all of those things with your assignment today. But that's where we're going to leave it. We'll start talking about slices on Monday. So I'm going to stop the video here. That was your instructional video. If you need help getting your assignment into Notability like I use so that you can actually work through it without having a paper version, then there will be a second video for you. So thanks for joining me for these notes, and I'll see you guys on Monday. Sorry, little PS here, just in case you're not watching the other video. I will be available by email all day, well, all school day, if you have questions. Also, if you are really having trouble and you think you need a Google Meet so that we can actually have a face-to-face conversation, just let me know. Send me an email, say I'm really struggling with this. Can we do a meet? I don't think we can share screens. If I remember it, I feel like I tried that at some point earlier in the year, and I think my permissions on my computer don't let me do it. But we can at least talk about it. I can look at my PDF while you're looking at yours. We can talk about it. We can practice using the right mathematical language so that we're both on the same page on what we're talking about. But if you need it, that is available. We'll try to get it as quickly as possible once you tell me that you need it. But if you don't need anything, if this seems pretty straightforward, then that's awesome. And I'll just see you on Monday.